Greetings. Welcome to the session on long-run costs. In the earlier session, we have discussed about the short-run costs. Now, let us understand the theory of costs in the long run. As we are aware, in the long run, there are no fixed inputs. Therefore, there are no fixed costs in the long run. Another important feature of the long run is there is greater level of flexibility as compared to the short run. Decision making in the process of production is very important because a wrong decision will lead to higher production costs and less profits. Therefore, the long run costs are very important because they help in careful choice of production technology that ensures lower costs of production. More specifically, long-run decisions pertaining to costs are referred to as planning decisions. Let us now understand the three important costs that are associated with long run. Long-run average cost, long-run marginal cost, long-run total cost. First, we will understand what is long-run average cost. Long-run average cost curve is referred to as an envelope curve and represents the average cost of production when all factor inputs are variable. It shows the minimum per unit cost of production at each level of output when the capacity of the firm is changed. LAC, or the long run average cost, is basically derived from the short run average cost curves. Look at the graph. The graph is showing the possible combinations of plant sizes that the firm can employ over a period of time. In the graph, it's clear that we have 3 plants and that the firm can employ over a period of time. In the graph, SAC1 represents cost of small plant, SAC2 represents cost of the medium plant, and SAC3 represents cost of large plant. In the figure, output is represented on the x-axis and the cost of production is represented on the y-axis. The firm starts with a small plant. It can produce at lower unit cost up to the level Q1. Beyond that point, short-run average cost curve seems to be rising. At point Q1 prime, the firm's cost with small and medium plants are equal as shown by point M1. In this instance, the firm has to choose between the available plant sizes to produce the maximum possible output with the minimum cost of production. Thus, the question is, should the firm produce Q1 units with the small plant or install the medium plant? Suppose if the firm expects the demand for the good in the future increases to level Q2, then it should opt for medium plant to produce Q1 level of output because the output is larger than Q1, such as Q2 are produced at minimum cost with medium plant. Thus, in other words, it means that if a firm wants to produce Q2 level of output in the long run, it should produce it with medium plant so as to minimize its cost of production. Let's look at the derivation of long run average cost curve from the short run average cost curves. The firm engaged in the process of production can adopt different methods of production and each can be represented by different plant size. Now, each plant is represented by different short run average cost curves. Look at the graph. In the graph, we have derived the long run average cost curves from the short run average cost curves. Each point on the long run average cost curve represents the minimum cost per unit for producing the corresponding level of output. In a nutshell, how are we deriving this long-run average cost curve? We are just taking the minimum points of the SAC, and then when you join the locus of these minimum points on respective SAC curves, we are able to derive the long-run average cost curve. Thus, long-run average cost curve is a continuous curve and represents the point of tangency of different short-run average cost curves. Suppose output level is less than Q1, the point of tangency between long-run average cost curve and short-run average cost curve is to the left of their minimum points. Similarly, for output levels more than Q1, the point of tangency between long-run average cost and short-run average cost is to the right of their respective minimum points. For Q1 level of output, the point of tangency between LAC to SAC to its minimum point is represented at point M, which is also the minimum point of LAC. Thus, the plant size whose costs are indicated by SAC4 is referred to as the optimum size or scale of the plant. Now, let us analyze what could be the relationship between the long-run production function and long-run costs. Look at the shape of the long-run average cost curve. The shape of the long-run average cost curve is a flatter U-shaped. The reason for this flatter U-shape of the long-run average cost curve is nothing but the operation of returns to scale. As the plant size expands, the average cost of production decreases. And the main economic logic behind this reduction in the per unit cost of production is economies of scale and diseconomies of scale. While economies of scale tries to decrease the cost of production, diseconomies of scale tends to rise the cost of production. Let us now understand what is economies of scale and diseconomies of scale mean in the process of production. Economies of scale means reduction in the per unit cost of production, that means average cost of production with the expansion of output. While diseconomies of scale is increase in the per unit cost of production with the expansion of output. Another important thing we need to understand is the economies of scale exist only up to the optimum plant size. Look at the graph, that is the point SAC4 is representing the optimum plant size. When you look at the turning up of LAC curve, it implies that the cost of production is increasing because of the firm or industry is experiencing decreasing returns to scale. So, in a nutshell, we should understand LAC curve is an envelope curve because any time in the production process, there is no possibility for the short-run average cost curve to lie below the LAC curve. Now, let us understand why long-run average cost curve is referred to as a planning curve. It is regarded as a planning curve because this curve helps the firm in the selection of most appropriate plant size in the process of production. The LAC is referred as a cost frontier because it distinguishes the inefficient levels of the costs from the efficient levels of the cost. Thus, any point above the long-run average cost curve can be achieved, but seems to be inefficient production because it is incurring higher cost of production. And similarly, when you look at any point below the LAC, it represents efficient but not possible to achieve with the given state of technology. Now, do you think always LAC curve will be a U-shaped curve? Not necessary. In certain cases, there is a possibility for the long run average cost curve to be horizontal straight line. Now, what does this horizontal long run average cost curve indicate? Just to recall, if a curve is horizontal, it means it is constant. From that, we can infer that the firm or industry involved in the process of production is experiencing constant returns to scale. Let's look at this graph to understand what this horizontal LAC means to us. The flat bottom of LAC curve in the graph indicates that small firms coexist side by side with large firms in the same industry, as a result of which there are short-run average cost curve 1, SAC 2 and SAC 3. That means there are 3 optimum plants. The flat portion of the LAC is formed by the lowest points of many SAC curves. In a nutshell, we should understand if in case LAC is horizontal or straight line, it means the firm or industry will enjoy constant returns to scale from their production activity. Now, let us understand what is long run marginal cost. Long run marginal cost basically measures the change in the long run total cost per unit change in the output. The values of LMC can be mathematically computed as follows. LMC is DLTC divided by DQ, or LMC is D into LAC into Q by DQ. The relationship between LMC and LAC curve is same as that between the short run marginal cost curve and average cost curves. Let us now look at the derivation of LMC curve from the short run marginal cost curves. Look at the graph. In the graph, SMC represents short run marginal cost curve, SAC represents short run average cost curve, LAC represents long run average cost curve, LMC represents long run marginal cost curve. So, LMC is basically the locus of points of intersection of SMC, that is the short run marginal cost curves, with the vertical lines drawn from the point of tangency of the corresponding short run average cost curves and long run average cost curves. Let us now understand long run total cost. Long run total cost represents minimum total cost of producing each level of output. In the short form, LTC for any level of output can be achieved mathematically by multiplying output by the long run average cost. For the output, the same can be stated as follows: LTC equal to LAC into Q. The most important feature of LTC curve is it has an inverse S-shaped curve which starts from the origin. It can be determined from the short-run total cost curves and it envelopes the short-run total cost curves. Let us look at this graph which will enable us to understand how LTC can be derived from respective STC curves. In the graph, LTC represents long run total cost curve and STC represents short run total cost curve. It is clear from the graph that LTC is a continuous curve. Each point on the LTC curve is formed by a point on the STC curve. The point on the STC curve shows us the most suitable plant size, which means minimum cost of production. LTC curve, which is tangent to all the STC curves, indicates that other plant capacities that the firm could build in the long run. Always remember, STC curve, that is the short-run total cost curve, will be below the LTC, that is long-run total cost curve. That's why long-run total cost curve is also known as an envelope curve, and it envelopes all the short-run total cost curves. The striking difference between the shape of these short-run total cost curves and long-run total cost curves is that short-run total cost curve starts from the level of fixed costs, but the long-run total cost curve will start from the origin. Can you understand why is it like that? Recall that there are no fixed costs in the long run. Another important thing we have to understand when you look at the shape of the LTC curve, it is reflecting the operation of law of returns to scale. Another important thing we need to understand about LTC is it represents minimum total cost to produce the particular level of output and the appropriate plant size to be built to produce that level of output. Let us now look into the current developments in the theory of cost. Do you think the theory of cost which we have learned is relevant in the practical world today? Definitely yes, but we do have some recent developments that have taken place to explain the theory of cost with empirical support. Let's see what does modern theory of cost enables us to understand. Modern theory of cost explains that the cost curves may not be U-shaped in the short run, and the long run cost curves are not enveloping in the practical world. Let's now understand the basic logic behind this. According to modern theorists, TVC, that is the total variable cost, is a straight line with a positive slope starting from the origin. Look at the TVC curve in the graph. If you look at the shape of the TFC curve, it's clear there is no change in its shape. It still holds good that it is still a horizontal line which is parallel to OX axis, representing that fixed costs are fixed at all levels of output. Look at the TC curve. The TC curve is a straight, positively sloping line starting from the level of fixed cost, which is very much different from that of our traditional theory of cost. In the traditional theory of cost, we understood the curve was assuming an inverse S-shaped curve, but according to modern theorists, the total cost curve is a positively sloping curve. According to George Stigler, the average variable cost curve is a saucer-shaped curve. It has a flat stretch over a wide range of output, representing built-in plant reserve capacity. This reserve capacity helps the firm to meet seasonal variation in the demand at the minimum cost. Let us understand this with the help of a graph. Look at the graph. It's clear that the falling portion of AVC indicates decreasing cost because of better utilization of factors of production. The rising portion of the AVC indicates overutilization of capacity. The flat stretch from QA to QB is due to reserve capacity. Let's now look at average fixed cost according to modern theorists. Now, they believe that in some reserve capacity exists in the plant, land and building. Look at the graph. It's clear from the graph, boundary L is the largest capacity plant representing an absolute limit to the expansion of output, and boundary S is the small unit machinery of the firm which acts as a limit to the expansion of output. We can therefore understand that there is no absolute limit and the firm can increase its output till it reaches the absolute boundary. AFC is therefore represented by CD in the figure. If the firm expands its output by purchasing some additional small unit machinery, then AFC curve shifts upwards and starts falling as indicated by the curve in the graph. Let us now look at the relationship between average cost and marginal cost with the help of a graph. As we are aware, average cost in the short run is summation of average fixed cost and average variable cost. Average cost according to modern theorists is continuously declines till it reaches QC level of output as indicated in the figure. At QB level of output, the reserve capacity is exhausted. The AC curve tends to rise beyond the QC level of output. Because of this, MC curve assumes U shape and intersects average variable cost at its minimum and tends to be constant till it reaches QB level of output. Beyond QB level of output, MC tends to rise and intersects AC, that is the average cost, at point C, which is the minimum point, and then starts rising after that point. If you look at the view of long run costs, according to modern theorists, they view LAC as L-shaped and it is not an enveloping curve, and the logic or the reason they claim to say is costs in the long run can be divided into production costs and managerial costs. Therefore, with the expansion of output, production costs will fall continuously, and as the scale of operation expands, managerial costs will increase, then thereby resulting in L shape of the LAC. Now, L shape of the LAC indicates decrease in the production costs more than the rise in the managerial costs. As a result of this, the long run average cost falls smoothly and remains constant as output expands. Let's now establish relationship between long run marginal cost and long run average cost curves. Look at the graph. It's clear from the graph that LMC curve intersects the long run average cost curve at its minimum point and then remains constant with the flat stretch of the LAC curve. When you look at the long run total cost according to modern theorists, it is a positively sloped line. Look at the graph. Thus, it can be concluded that the modern theory is basically a modified version of traditional theory, but based on empirical cost studies. Let us summarize the concepts which we have learned from this session. long-run costs are very important in the decision-making process. The long-run decisions of the firm are referred to as planning decisions. Long-run cost curves are derived from long-run production function, that is returns to scale. The basic difference between short-run cost curves and long-run cost curves is that in the short run we have fixed costs and variable costs, but in the long run we do not have any fixed costs. In the long run, we have three types of costs which are important for the decision making. They are long-run average cost, long-run marginal cost curve, and long-run total cost curve. According to traditional theory of costs, cost curves are derived from the respective production functions, and they are usually U-shaped and enveloping. Modern theory of cost states that practically cost curves cannot be U-shaped curves, and long-run cost curves do not envelop the short-run cost curves. Answer the following questions. Explain the reason behind why long-run average cost curve is known as a planning curve. What do you infer if the long-run average cost curve is a horizontal line instead of a flatter U-shaped curve? Discuss the significance of long-run marginal cost in the theory of cost. Describe how AFC and AVC differ conceptually in terms of traditional and modern theory of cost. For further reference, you can look into these following two books: Modern Microeconomics by Koutzianis, 2nd edition, published by Macmillan Publications; Economics by Paul Samuelson and William D. Northers, the latest edition, published by Tata McGraw-Hills. Thank you.